we're going to be talking about evolution, which in the end, I'm going to try to do something that I believe is impossible to do, which is to get us to the point number 7 of rethinking or reconsidering how we imagine and the images that pop into our heads when we think about evolution. So I want us to eventually get to the point where we can think about evolution as a way of expressing the diversity and variation of life, biological life, and how it has changed over time, but not in a directional fashion. So to do that, we're going to be going into some stuff that is kind of before Darwin and around Darwin. Something happens in our heads, I think, whenever we hear the word evolution. We get two things that happen. These images or these ideas come back to us, perhaps from high school, perhaps from popular culture. We think Darwin and survival of the fittest. In fact, 3 of you talked about survival of the fittest, even though the phrase does not appear in the whole textbook, not at all, but somehow it comes in there that is the essence of evolution. So we're going to be trying to deal with those, how we got those ideas into our head. I'm not sure if we can dislodge those ideas because they're so entrenched, but we're going to try. We're going to at least explain how you got those ideas. So we're going to start out with this class will cover up 1 through 4, basically variational evolution. It will get us right to the modern evolutionary synthesis. Variational evolution is what was proposed by Charles Darwin and Alfred Russel Wallace in a paper they presented together. They don't teach you about Wallace in high school, but we'll talk about him too. So then in Wednesday's class, we'll do the modern evolutionary synthesis, the extended evolutionary synthesis, and then try to do the rethinking. As I said, the goal here is to get us to say goodbye to the idea of survival of the fittest. Like I said, that's going to be hard to do. It's hard to dislodge that from our heads. And one of the reasons, you may not know this, but one of the things that is underlying our ideas about evolution and this idea of perfection, ascent, fittest in general is the underlying idea that there is a great chain of being, which you probably haven't heard about that one. But we're also going to be trying to say goodbye to that, or hello and goodbye as it is. Any questions? Any things so far? Statements? Ah, yay! All right. Getting better and better. All right, so let's start back with kind of a general idea about the word theory and how it is used. As Muckle, González, and Camp tell us, I think it's pretty true. Outside of science, outside of the community of science, when somebody comes into your room and says, I have a theory, you'll probably think they're crazy. Theory has come to mean like the opposite of a theory. It's like a nutty idea. In fact, we have a whole genre of people who are conspiracy theorists. Like, what's conspiracy theories? And so it's come to mean the opposite, basically, of what a scientific theory is. So I'll talk about in a second that when scientists use the word theory, it has a pretty specific meaning, and it means that the idea has been elevated to the level of very good science, something that is not perhaps absolutely proven, but has been pretty well established. You may have heard about a couple of theories in science, like the theory of gravity or atomic theory. And, I mean, I don't have to go around talking about whether I believe in the theory of gravity or not. I don't go around saying I believe it. I don't have to believe it. It's just there. It's just kind of affecting me whether I believe it or not. So it's kind of the same thing with evolution. I'm not really asking you to believe in it because, well, Cass, what do we know about science and, well, know now about science and religion and belief?
Apparently they can coexist, which is not something I have ever been taught. Everyone has always said you can choose to believe religion or evolution, but nobody has ever said that.
Oh, who told you? No, I don't know. I'm not going to pick on the people who told you that, but they should not have told you that. Right? Religion is a belief system, and you want to believe what you want to believe. And science is an explanatory system for the world. They operate in different realms. Nobody's trying to take away your religion here, in the same way that I'm not asking you to believe in the theory of gravity. In fact, if we get into this belief stuff, Delaney, what might happen to us if we get too entrenched in our beliefs about things? That is sort of anti-scientific, because science science has to be able to self-correct. It has to be able to change. If it can't change, not science. If you can't change your stuff, it's not science. That said, the theory, when it comes to a theory, as Muckle, González, and Camp say, that's usually as good as it gets. A theory is an idea which has been supported by a number of hypotheses and data and explains a whole bunch of things in the natural world. So although we always have to be open to the possibility that things are going to change, and the ideas of Darwin have been modified a ton, as we'll see, but the general framework, the general theory of evolution has been abundantly established. And so, as Muckle and González and Camp tell us, evolution is actually a fact. We can observe it occurring. In fact, we've been observing it occurring for the last couple of years as all these variants have come out, and we've been fighting the variants, and they've been mutating and evolving, and and we're in this race to get our new booster shots and all this stuff. We can see evolution as a fact happening. And by extension, we obviously can't observe the dinosaurs and stuff, but we have pretty good evidence that this is the way things went down in the natural world. So in the old days, I don't know if this is still happening, people want to put a sticker on certain science books that says evolution is a theory. And by doing that, I think they were trying to draw upon that everyday use of the word theory. It's just an idea. It's just it's a crazy thought that some scientists have, when in fact, at least at the level of science, that means you've reached not the level of absolute certainty and absolute proof, but it's something that can explain a whole bunch of things and has a lot of evidence behind it. So again, this is nobody's asking anyone to change their religious views. And in this class, of course, even if you don't want to believe, that's fine. But I do want you to be able to explain what it is and why it is that science finds this to be a useful framework for understanding life. So before we get into ideas about evolution, I want to talk about what was going on in Europe before these ideas came around. So long before Darwin, I'm going to say what we call the Middle Ages, or sort of late 16th century. in Europe, some of the people there were combining ideas from biblical texts, from the Bible, the creation stories, together with the ideas of Greek philosophy. And in some ways, this is a funny combination, because the Greeks believed that the world had always been and would always be, that it was a forever kind of thing. And so they had the notion that the world was always around. Whereas in the biblical account, as we probably know, the earth was pretty recent. If you went into Genesis and went into the begats and went back to Adam, it seemed like you got to about 6,000 years ago when the world must have been created. And in fact, there's that quote from Archbishop James Ussher, who calculated the date of the Earth's origin as 4004 BCE, before Common Era, BC, as we used to say, at 9 a.m. So, it was about 6,000 years ago that the world would have been created. The thing that both of these ideas had in common was an idea that we call essentialism. And this was the idea that whatever was out there, the natural world, the species or the kinds of creatures that we saw had essences that had either been given by God during the creation, or in Platonic terms, in the Greek philosophy, all living things, and I think all things in general, were sort of copies or imperfect realizations of an ideal out there. So if we see cows in the world, those are runoffs from the ideal, wonderful cow that is out there and exists eternally. But the idea is things don't change. They have essences which were established either at creation or endure eternally, and that's how these things were combined. And there's a lot of these kinds of graphics, but this is one from 1579, which depicts what we call the great chain of being, where you have God and the angels at the top, and then you have people, and then the more beautiful animals, and then you get down to the worms and the dirt, and finally the fallen angels, the devil. And what this did is it combines together the Greek ideas about perfection and ascent with Christianity, because all of these things would have been created by God, and that they were ordered by sacredness or perfection as a chain going from the worst, the bad, to the good, or up to the divine creator at the top. And so this was a very, it's a really interesting and kind of fascinating idea that was made, and it combined a lot of the philosophical ideas about how the world works, and was a pretty good description for what was happening. And in fact, the great chain of being was at the time, a framework for classifying biological creatures. As we talked about in the class on We Are Primates, Linnaeus was born and died before Darwin, and gave us those names like Homo sapien and Pan Paniscus, and all those wonderful classificatory terms of genus and species, was operating within the idea that he was simply ordering God's creation. And in that ordering, put humans together with chimpanzees and others into the primate order. And so what this was an essentialist classification of the kinds of the earth, that all these things were divinely ordered and could be put in a line. Now, it turned out later on that this framework was quite useful for the idea of evolution because it showed the relationships among various creatures. But at the time, they weren't thinking about it as in the framework of evolution. So, like I said, this is a quite beautiful classification scheme that had a wonderful depiction in art and other places. And what was interesting here is that the thing that kind of interrupted this scheme was not a new idea. It's not that somebody came along and said, I don't believe in God or Plato, or we want to we have a new hypothesis. What happened is that people started to find stuff, especially fossils, of species that were extinct. So there were creatures that were found that were not in existence, or the remains of creatures that were not in existence in the contemporary world. And so, I mean, one of the first things they tried to do was say, aha, must not have made it onto Noah's Ark. Must have been flooded out, and so this big creature would have eaten all the giraffes anyway, so Noah had to let it go. So it didn't make Noah's Ark. So that was one explanation. But they also found creatures that were pretty similar to existing ones, but kind of different. And so this was a puzzle too, because, you know, these things looked kind of the same, should have been able to make it onto Noah's Ark, but they were different. They weren't quite the same. And so what this did was to cause people in the natural sciences in Europe to revise these ideas that species could not change over time, that they had their essences. They realized that species there had to be change. There had to be changes both in what kinds of creatures were around, some of them had gone extinct, and how the creatures changed to be what they are today. So the ideas came after the evidence in this case. The other thing that was happening is the geologists started to realize that the world, it would have been impossible to form the geological features of the world that we see in only 6,000 years. So the geologists began to go into different places, perhaps outside of Europe, and see that there was evidence that the Earth was a lot older than it was, than the 6,000-year-old model. Now, one of the first ideas about evolution was the idea of transformational evolution, which is most associated with Jean-Baptiste de Monet de Lamarck, who, again, this is 100 years or so before Darwin. And what Lamarck was doing was trying to think about the changes that you could observe in species over time. And so his idea, well, Christine, what was his idea? The thing that you do over and over again in your lifetime can be passed down to the next generation. So what's something you're good at, Christine? What do you do a lot of? Sorry. Let us say you're a good piano player. Play piano excellently, and that you could acquire the characteristic of piano playing because you did it so much, and then that would be passed down to your offspring. Now, this is also sometimes known as Lamarckian evolution because it's associated with Lamarck. And the idea is that in response to your changing environment, the organism is transforming itself and then passing those characteristics along. So you're correct, Christine. That's the piano playing. Not the best example. My favorite is the giraffes. Anybody do the giraffes in high school? Remember the Lamarckian giraffes? Actually, they might have talked about those wonderful giraffes in here. Ah, yes, on page 66, the giraffes. The idea of the giraffe as featured in Lamarckian evolution is, you have this short-necked giraffe and it needs to get up to the leaves on the tree, and so it's stretching its neck and it's stretching its neck, and then it can pass along that longer neck to the next generation. Now, of course, we know the giraffe example is mostly used to tell us how evolution does not work, because you can't pass along your piano playing or your stretching of the neck to the next generation. Instead, we were introduced, or the idea came up of variational evolution. And that's where our good buddy Charles Darwin comes in. Variational evolution is the idea that the variation exists already in the generation. And so Darwin, of course, was on his voyage around the world on the Beagle, and then stopped off in the Galapagos Islands and observes those finches and their variation over the islands. Darwin comes back and is working on this idea and writing about it for 20 years, but he was kind of reluctant to publish about it because he thought it might be too controversial. Alfred Russel Wallace was off in a malarial area in the tropics, and some people say he was hallucinating under a bout of malarial fever, came up with this great idea, wrote it to Darwin, and Darwin's like, wait a second, that's my idea. So they actually published it together. But the idea is that you have variation over time and space, and that the species that we see today are descended from a shared ancestral species. And so the idea was that the mechanism of evolution is natural selection, or as Darwin preferred to call it, descent with modification. So you would have offspring that were different, and that those offspring would then propagate at different rates. So they proposed this together. The idea is now mainly associated with Darwin because he wrote the best book about it, which is On the Origin of Species, and had done a lot more kind of work on the idea. Wallace had a similar idea, but hadn't really written it up to the extent of Darwin's research. And of course, this is known to us as the mechanism of natural selection. I want to emphasize here the idea of evolution, of transformation, of organisms changing had been around long before Darwin. So what Darwin and Wallace gave us was this idea of how it worked, not that it happened, but how it worked. So this is the idea of natural selection. And what's crucial here is that you need variation or diversity as your groundwork or framework of evolution. So what Darwinian ideas tell us is that what makes a species possible and what makes a species exciting isn't its essence, but its variation. And if you don't have that variation or diversity, you're not going to have natural selection. You're not going to have the evolutionary process work very well. What else do you need, Alex? You don't just need, what else do you need for natural selection to work?
Like adaptation to the environment
Adaptation to the environment, and you need, what if there's so much stuff in the environment that everybody's just happy and reproducing and living on? What will happen then? What do you need also? So let's say that, let's deal with the giraffes for a second here, as long as we're talking about giraffes. Let's say there's all kinds of leaves everywhere, and all the giraffes can be happy and reproduce, and everybody's happy. Will that work? Well, you need, yeah, I'm kind of bugging you to say something I want you to say, which is you need competition, which I think you talked about in your post, which is you need to be, you need to have, if everybody has all the resources they need and there's no competition for the resources, then nothing, everybody can reproduce happily and nothing's going to change very much, or it'll change in different ways. So the idea is that you have this variation. You have a competition for resources. Those who are able to reproduce more successfully, there's a differential in their reproduction, are going to pass on their traits. And Alex, as you said, become more adapted to their environment. And of course, importantly, you need a mechanism of heredity. Like if those traits need to be passed on in some way, or else, again, it can't really work if you're not passing on the beneficial traits. So hugely important idea, one of the most revolutionary ideas. Again, it wasn't the idea of change or evolution, that was around already. It was how this change occurs. Now, in some ways though, what people did was take this idea and kind of put it on to the great chain of being. So the idea was that, and this especially comes out in Darwin's later book called The Descent of Man, the idea was that every creature was on a line, and that humans or man in those days were at the top or the most perfect. Didn't have necessarily God in there because that was not important anymore. But basically the classification scheme and the idea of ascent and perfection that underlied the great chain of being was still the part of the evolutionary framework. And that is why, as we'll discuss with humans, people went around looking for missing links. The idea was that there was the links on the chain of being, and you had to find the things that filled in this gradual evolutionary process as creatures got better and better. And so this caused a lot of actually problems in looking for, if you're looking for missing links rather than common ancestors, it'll send you on a lot of dead ends, especially in human evolution, which we'll talk about on Friday. So again, this is what happens during Darwin's time, is it's not necessarily the great chain of being gets displaced, it just gets mapped onto the idea of evolution as ascent and perfection. Now, natural selection in Darwin's time is thought about quite differently than it is now. So even Darwin himself was not, he originally didn't like the word evolution. He didn't think it correctly spelled out what he was getting at, and he preferred the word descent with modification, or the phrase descent with modification. In fact, in the whole Origin of Species, that whole many page book, the word evolution only appears twice, and that's in the last page. And so descent with modification was the way that Darwin preferred to talk about this. And I sometimes wonder if people would be that upset about the idea of evolution if we just called it descent with modification, because it's more difficult to get angry at that. Everybody can see descent with modification. So that was one thing that happened, is people talked about evolution rather than descent with modification. And then he also eventually borrowed a phrase from the sociologist Herbert Spencer, which was survival of the fittest. Again, in the Origin of Species, Darwin did not use survival of the fittest, but Herbert Spencer, who was a person who was actually very concerned with humans and human societies, and had some very interesting ideas, not interesting, very bad ideas about people who really were not the fittest, read Darwin's book and wrote him and said, hey, this corresponds to my idea, survival of the fittest. And Darwin eventually borrowed that and used it in his own work, and it's become very associated, of course, with evolution. Some people believe that it perfectly describes evolution. Many of us in anthropology think that this might have been a mistake. And there's various reasons for that being a mistake. One is that the idea of fittest or fitness in evolutionary terms, if you get scientific about it, it just means creatures who are able to reproduce more. So it's not a measure of fitness as a kind of trait or absolute thing, because it's impossible to measure fitness as some kind of absolute trait, because fitness can only be measured against an environment, adapted to an environment, as Alex told us, but that environment is always going to be changing. And so a trait that is adaptive in a certain environment, if the environment changed, might become maladaptive. And as we talked about with the evolution of primates, there's always going to be trade-offs. So you might become more fit in terms of your eyesight, but you might become less fit in terms of your nose and ability to smell. So all the traits that we have, and as they evolve, there are always going to be trade-offs and ups and downs to them. The other thing that we've realized over the years is the idea that not everything can be explained by being adaptive to an environment. For example, it'd be extremely difficult, perhaps impossible, to explain how wings and flying developed simply from natural selection. So the biologist Stephen Jay Gould, who gets mentioned here at the beginning and a couple times, together with Elizabeth Verba, came up with this idea of what they call exaptation, which is that certain traits that are adapted to a particular environment then become useful in a very different way in another environment. So wings are actually one of the classic examples. The idea is that insects and other creatures develop protuberances to cool off the body. So they were adaptive to one environment, but eventually became something that you could fly with. That's an exaptation. It's a trait being used in a new environment. And at that point, then new natural selection processes could kick in, which would help you adapt to flying. I mean, I guess, not to extend this too much, but there's just no way if I just kept flapping my wings, arms, and jumping that I could start to fly, and my offspring wouldn't have like web to fit. It just can't work unless you have this other thing going on, which is exaptation, which is the idea that you can become adapted to one environment, but that trait can get used in a different environment. So we have to be, I mean, it's not that survival of the fittest is is completely wrong, but we have to be careful where we apply it because the environment is changing and it's very difficult to measure absolute fitness. So, yes, I said that we would get to variational evolution and then what is called the modern evolutionary synthesis, which is where we end our reading here, or what gets put together. So the modern evolutionary synthesis. So basically, during Darwin's time, it was obvious that traits were inherited, but people didn't know how those mechanisms worked. They basically thought it was by something called blended inheritance or pangenesis. Kind of like if you had a bucket of red paint and a bucket of white paint, and you put them together, you get pink paint. So the idea was that creatures inherited the traits of their parents, but in a blended form, and nobody really knew how that worked. Now, at the same time as Darwin, there was Gregory Mendel, who was off in a monastery, didn't know Darwin. Mendel didn't know Darwin, and Darwin didn't know Mendel, and he was doing breeding those pea plants and stuff like that, and basically started to understand how traits were passed along, at least for the pea plants. And like I said, Darwin didn't know at the time, but this was disproving the idea that these traits were just blended together. Oh, Cass, you wanted to see these things. What are these? Punnett squares. Why did you have to do these? And yeah, what? Why? That's a bad question. Why are these important? What difference does it make? Why don't we just get a bunch of half purple flowers there?
So like the traits aren't completely disappearing or entirely blending. So they're showing up at different levels of prevalence based on which parents' genes are those, but it's coming through what's flowers.
Yeah,
It shows that the traits don't disappear even if they're not entirely visible. It can still be passed.
the traits don't entirely disappear. They can still be kind of passed along and reappear. I mean, eventually, I guess they might disappear, but yeah, a lot of them can reappear over generations. This is hugely important because it means that the variation gets preserved, as you put it very nicely, as individual units, and it can be a sort independently. If it all just blended together, then it would dramatically reduce the variation that was possible in evolution, the stuff that evolution had to work on. If all the flowers just turned out to be short, I mean, if we mixed a short pea with a tall pea and they all came up medium and they were going to be medium forever and ever, and you don't have that much variation that the process of evolution or natural selection can work on. So we won't actually see the Punnett squares come out, in part because simple Mendelian genetics works decently with pea plants, but humans are much more complicated than that. As Muckle, González, and Camp say on page 69, there's relatively few human traits are passed on by simple Mendelian genetics. Some people might say none, but very few. We used to think eye color, but even that turns out to be influenced by multiple genes and multiple genetic tracks. But what happens is that after Darwin is gone and after Mendel had died, people eventually got their work and were able to fuse it together in the 1930s, 40s, and 50s to come up with what is called the modern evolutionary synthesis, which puts together the natural selection mechanism that Darwin had described with what Mendel was describing, which would be the basis for genetics and heritability. And so when we put again, they had both passed away, and it was different people putting their work together after that. But that's where we get what is basically taught to us in our biology classes today, and known as sometimes known as neo-Darwinism, sometimes known as, but probably better known as the modern evolutionary synthesis.